Hello. Today we are looking at a question from the math series of papers. This is 2015, and this question is from question 1 part F. And we've got a bit of notation here. For a real number x, we denote by, it's called the floor function. So that expression there, the largest integer less than or equal to x, and then let f of x equal x over 2 minus the floor function of x over 2. And then it says the smallest number of equal width strips for which the trapezium rule produces an overestimate for the integral is it 2, 3, 4, 5, or it never produces an overestimate. So let's look at the integral. It's for that function going from 0 to 5. So I think we can start by drawing the function. Let's think about what happens here. We're going to look to start with, between 0 and 2. If we have x is 1, we have a half minus, well, a half, the floor of a half is 0, so it's just a half. So this function here will be x over 2 all the way up to 2. So let's write that first. So this is 2, and it's going to be a half. So I'm going to draw it like this. So if it's a half, that means it must go up to 1 up here. And then as it goes above 2, we're going to be subtracting. To start with, it's going to be 2 over 2. So we're going to be subtracting 1. So the 1 is there. That takes us back down to here. And then it just repeats. So if we're going up to 4, it just repeats like that. And then finally, for this integral, we need to go from 0 up to 5. We need to just go halfway up. So here we are at 5. This must be a half. And that's what our graph looks like. Let me just put some dotted lines in to try and connect it up. We want to know, well, we want to estimate the area under the graph. Well, to start with, we can write the answer down. The area under this graph, we've got 3 triangles. The area of this one is 2 times 1 divided by 2, which is 1. Same for that one. And this one is 1 times a half divided by 2, which is a quarter. So 1 plus 1 plus a quarter equals, let's keep it as a decimal, 2.25. Okay, and then we're going to use the trapezium rule to make an estimation for this. So I'm going to start with 2 strips, because that's the first thing it says here, is 2 strips. And I'm going to draw the 2 strips over the top of this diagram to start with. So the 2 strips, if there's 2 strips, it must go halfway. So this is where the strips divide up. So this must be at 5 over 2, maybe a bit nearer to there, that's 3. 5 over 2. So we're going to go up to here, and then that's going to be the first strip finishing there. So that's going to go from there down to there. And then for the second strip, it's going to go from here to here. So we've got our 2 strips now. First one is a triangle, as it happens, and then the second one is a trapezium. So we can now write down for 2 strips. For 2 strips, the area is approximately equal to, using the trapezium rule, a half times the width of the strips, which is 5 over 2. And then the first strip is 0, plus 2 lots of the middle strip. Well, this is 5 over 2, and we're halving it, because that's the function. So it's halving 5 over 2. So it becomes 5 over 4. And then the end one is at a half, plus a half. So the 2 ends plus twice the one in the middle. This will give us A half times 5 over 2 is 5 over 4. This part here is 5 over 2. There's a mistake here. That's not 5. It's 1 over 4. 1/4 here. So this is a half plus a half, which is 2 lots of a quarter. That's a half. So you end up with 5 over 4, which is less than 2.25. So clearly 2 strips is an underestimate. Now let's look at 3 strips. I need to draw my diagram again for 3 strips. Let's draw it over here. 3 strips now. 3 strips. So this bit's the same. It's going up from 0 to 2. 0 to 2. Again here. 2 to 4. Finally 4 to 5. Let's get these a little bit extended. Okay, like that. So that's 1 up there. These match up down here. And then we're going to have 3 strips. So 5 divided by 3 is 5/3. So 5/3 is going to be, say, here. And then 10/3 is going to be, say, here. So we get 1, 2, 3 strips. Do it in green. So this is going to give us a triangle again. This time we're going to get 2 trapezia. 1 here and 1 here. If I was in the exam and I'd drawn these and we're short of time, it just looks as if it's an overestimate now. We've got more, particularly over here. So I would probably have a guess at 3. But let's just convince ourselves of this. The area is approximately equal to half. The width is 5 over 3 times 5 over 3. Brackets 0 plus 2 lots of, right, this time we've got 5 over 3 here, so we need to halve that, and we get 5 over 6. The second one, if this is 2, and this is going to be, we're going to be adding 3 is here, and it's 1/3 more than 3. So it's 1 1/3. 1 1/3 is 4/3, but we only want half of that because of that's the function. So it's 2/3. And then finally, the last one again is a half. So that's a half here. Let's write this out. 5 over 6 times, what have we got in here? We've got 2 lots of this. So that's 5/6 plus 4/6 is 9/6. 9/6, 9/3 plus a half is going to end up being 7 over 2. This equals 35 over 12. 35 over 12. That's nearly 3. Nearly 3, which is clearly bigger than 2.25. So the answer then is 3. And that's it.